All right, hello everyone. I'll try to be as kind to your hangovers as possible and hopefully sneak some slightly unthought out details past you in your post-drunken stupor. So my name's Oliver Hookins. I'm a principal engineer in the location-based services at Nokia, and I'll try to tell you a little bit about how we use Puppet for deploying our services. So, who am I? I'm a rockstar sysadmin. No, seriously, all egotism aside, I can somewhat take credit for that title. But seriously, I've been using Puppet since about 0.23, which slightly belies my skill level. I should really be a lot better at it than I am. I've been working with Nokia for about the last 1.5 years in location-based services. And before that, I was at Anchor Systems, who manages GitHub's infrastructure using Puppet, and obviously everyone's familiar with them, although I can only take a little bit of credit for that work there. And like perhaps some of you, I've got a love-hate relationship with Ruby. So basically a little bit about what we do so you understand some of the problem domain. We do location-based services, basically mapping and routing and places and things like that. The applications that we deploy, a lot of them are back-end services, but we've got a lot of them that actually are used to provide the web front end and the phone client back-end services. We've got a rapidly moving environment, so we're trying to compete with some of the big boys whose names I don't really need to mention. We need to stay competitive, so we've got to roll out applications very quickly when we're adding new features. This is probably not dissimilar to many of you. And Nokia is an extremely large company. We've got something like 125,000 employees, although maybe a few less after the desymbioning. We've got reasonably heavy change control in place. We're trying to make some changes to this. The reason this happens is if you think about Nokia as, just about everybody knows Nokia as a mobile phone company, not a services company. And when you're shipping a mobile phone, you need to get that right. Before you can ship that off to the stores, it needs to be 100% working. And so when you're producing some piece of hardware, you need to make sure that you've got very strict change control in place. And this obviously does not apply very well to web services where you can, something goes wrong, you just roll it back or you roll forward. It's really not the same problem domain at all. And unfortunately, this transition has not really been made very well. But with the help of Puppet and some of the work that we're doing in these areas, we're trying to make some changes to our change control. So some obligatory screenshots. Some of you may know this. This is our web front end. We've also got the mobile phone client. Looks a little bit different, but basically these are both using the same back-end services to provide the mapping, public transport, routing, all this kind of stuff. The phones tend to have a little bit more of a concentration on navigation and places, but basically the development teams that I'm working with are responsible for just about everything. Most of the stuff, obviously we're not deploying stuff to phones using Puppet, so when I'm talking about our use of Puppet, it's primarily in deploying the back-end services, but also the web front end as well. So I'll talk very briefly about the kind of problem domain, the issues that we're trying to solve. We're trying to get deployment consistent across environments, and by this I mean we don't want to be using one particular technology to deploy to our R&D environments and then suddenly change technology over. So, for example, one thing that was happening before, primarily for convenience, was some of the QAs were deploying the applications using WebAstrano. Now that was fine, that suited their model pretty well because they could plug in a number and say, I want to test this version in QA, and that would all work fine for them, but it completely breaks this consistency. And if that works for them, and then they deploy to staging using Puppet and everything falls apart, then we really don't know what's going on. So I really wanted to make sure that we've got the same deployment technologies or same deployment strategy in our entire system. So right from the very, very earliest stages of R&D through to staging and production. I wanted to reduce duplication of effort. So again, this is something that I can't see anyone not wanting to do. You know, you don't want to say, you don't want to provide the same configuration items in all of your different environments. You know, the config files will look generally the same. You don't want to be printing out the entire thing for every different environment, even though all of the keys are the same. It's just the values that are changing. Obviously, it's a lot more complicated than that, but basically only trying to describe the changes between each environment and keep that change set to an absolute minimum. And as a byproduct, reduce human errors in the process. I definitely wanted to increase testing. Our previous deployment mechanisms really didn't have enough testing involved. And this is another reason why, you know, this problem of change control can't really go away, because you can't really demonstrate that you have enough testing to justify it going away. Early feedback of errors is very important. This is more of a kind of traditional software deployment, software development thing where you do incremental testing. And as a result of testing and this rapid feedback, increased reliability. So I'll talk very, very briefly about the system that we had in place beforehand. Basically, it was an image-based system. It was written by, as far as I know, just a couple of guys, quite poorly documented and very poorly understood. It was very difficult to make changes. When you did make changes, you had to go through this entire image building process. It took a long time. If you had a problem somewhere at the end, you'd have to start the whole thing again, and you'd waste another few hours. So deployments could take hours or days. So where we started from when I got to Nokia was we were using Puppet already in our R&D data center, primarily for the convenience of my team, which was only 4 people at the time. This is probably going to be quite familiar to a lot of you. You know, you discover Puppet. You start using it to automate some of the basic things like you know, managing users or managing I don't know, mail configuration, NTP configuration, and that works really good for you. You know, it gets your job done faster, and you get to save time and work on more interesting problems. So we follow that general model. We had a bunch of machines, quite a few virtual machines. We were using this to make our lives easier, but weren't really using it beyond that. And so eventually word got out that, you know, we were using Puppet for our own purposes, and it was working pretty well. So someone suggested, well, why can't we use this to deploy our applications as well, because we've got this incredibly painful image-based system that we want to get away from. So we thought, well, you know, this is probably not a bad idea. So, you know, we tried some things, we got something working, and it worked pretty well. You know, we could get rid of the old system, but we still had some reasonably big problems that we had now hit as a result of basically letting the system grow organically. You know, there was only a little bit of planning involved, and at some point, you know, we hit some kind of architectural limitations in how we'd implemented it, and need to do some rethinking about how we were deploying using Puppet. So we now had some new problems. Node definitions. A lot of you will be quite familiar with the problems of node definitions, and I can tend to babble on about this for quite a long time, but I'll try and keep it very terse. Basically, the whole model of how it feels natural to describe your configuration. You want to say, okay, here's my global kind of view of everything. I want to say that this is kind of the platform that I describe for all my machines, and all my machines generally look pretty much the same. You know, they all are running you know, some flavor of Linux. They're all running an SSH server. They've all got some users, NTP configuration, and so on. You know, this general kind of idea of what all machines should look like is pretty standard. So that's something that you want to define at the top. And then as you go down, you say, well, these machines are in this data center, these machines are in this data center, so they've got, you know, a different NTP server, a different mail relay server, for example, And as you go down, you get more and more specific. And node definitions, basically, the whole idea of using, well, node inheritance and class inheritance don't work together very nicely. If you want to change some variables later on, you've got to use class inheritance to override that. I think these are problems that basically the system kind of works upside down to how you want to express your configuration. Anyway, I won't go on about that too much. We had a lack of trust built into our systems. So we initially just had one repository which controlled all of our R&D environments. Because of, I guess, a certain amount of distrust of how well this would work in production, we had two trees and kept all of our staging and production stuff in a separate tree. So anytime we wanted to promote something to staging and production, we'd have to do some copying of files in the different repositories. We had different node templates, we had different node definitions, and things tended to get a little bit out of sync. We made it that way intentionally because we weren't entirely sure how it was going to work, but in the end, this kind of broke things a little bit. The code was constantly evolving. So not only were our application teams making changes to their modules that controlled their application deployments, but we also had this common set of modules that provided the general kind of platform functionality. And all of these things were kind of evolving together. Someone would go, oh, I need to be able to create MySQL databases on the fly. Can you implement that? And we'd go, yeah, sure, we'll implement that for you. So we'd make those changes, and these things would be, all kinds of different things. And inevitably what would happen is these common modules originally got deployed with one application module. And what happened was, the next application that got deployed, in the meantime, we'd made some changes in the R&D environments to those common modules, and we need to deploy the application module over, and suddenly all of those things that we'd changed in the common modules weren't available in production. And the other way around also happened as well. So we, at one point, we said, well, let's just upgrade the common modules in production, but we couldn't do that because we still had some applications that were using the old versions. So this kind of code evolution kind of got things out of whack as well, and we had to make some rather ugly workarounds to get around this problem. We definitely didn't have enough testing to counteract the lack of knowledge. We've got a ratio of probably about 30 to 1 in terms of developers to sysadmins. In fact, probably more than that. We probably do have the resources to train up that many people at Nokia, fortunately, but it's still a lot of people. We don't want to train up that many people, literally hundreds of, an army of developers. It's time consuming. We can't take that amount of time away from, our primary function, which is developing the actual applications. So we had some basic testing in there, making sure that syntax checking was done, some basic kind of lint style checking, like no hard tabs, no Windows line endings were in our files. But obviously that's not going to pick up larger problems, and we just didn't have enough testing in place to make sure that the code really would work when it was promoted. And to some extent, we were the victim of our own success. So, we had some good stuff working in our R&D environments as far as systems automation goes from a general perspective. And the more people that heard about the way things were working, the more people that wanted to use the system. And we just couldn't fix the problems quickly enough and onboard more teams onto the Puppet system. One kind of major realization that I had when we were starting to refactor our code was came about halfway through last year when we were working with some consultants who were assisting with the application continuous integration pipeline for some of our teams. I was, I guess, trying to figure out how to solve some of these problems, and especially as far as testing goes. And the consultant came up to me and said, "Hey, I've heard about this new tool. It's called Cucumber Puppet. We could probably use this to do some more testing of our Puppet code. What do you think?" And I had a look into it, and my tertiary education background is in computer science, so I've done my reasonable share of programming. But as a system administrator, I really haven't been, I'm not a developer by any stretch of the imagination. I haven't done any serious programming for a long time. So behavior-driven development and test-driven development really were not things that had entered into my consciousness too much before. So I found this tool, and I had a look at it, and it really changed my entire way of looking at Puppet. You know, you think of Puppet as just another tool in your sysadmin tool bag. It's something that you use, but you don't really, you know, for the most part, think about this tool as any more than that, you know. And if you look at a tool like Cucumber Puppet, it's showing that you can really, you know, you have to change how you look at Puppet. It's not just some kind of tool. You write some stuff and it makes stuff work. It's when you're writing Puppet, you're writing code, and code can be tested, and that's a really powerful realization. And as soon as I discovered what we could do with this tool, it opened my eyes, and I thought, well, you know, there's really no limit to how much we can do in terms of testing and treating Puppet as just code. If you've used Cucumber Puppet, you might know that the language is somewhat verbose. You can, in fact, end up duplicating your manifests almost one-to-one, or even more than one-to-one. It still has a lot of uses. We're not entirely sure how we're going to use it going forward, but it's definitely a very good tool to have a look at. So we had some new goals. As I said, try and approach the whole process of using Puppet more like traditional software development. So I don't mean something like the waterfall model. I mean approaching your Puppet manifests as code and having these general kind of concepts like testability and continuous integration and life cycle and all that kind of stuff that software developers take for granted. That's just something that they do. And as sysadmins, I think we don't do that enough. Better versioning of components. As I said, we had our common modules, we had our application modules, and these things could tend to get a bit out of sync. So we needed to solve that problem. Testing, of course. As I mentioned, we've got some fairly rigid change control in place, and my opinion is that, I mean, you can argue as much as you want against management, but they're not going to just take away something without you justifying that. And my opinion about, you know, this whole thing is basically lack of trust and trying to reduce problems. And the one sure way to reducing outages and increasing trust is by increasing your amount of testing. If you can demonstrate, hey, this code works, I've got X amount of testing in place, you know, we're extremely confident that we're not going to break anything, then that's something tangible that you can then pass on to management and say, well, you know, let's make some changes and allow ourselves to be a bit more rapid in our deployments. Some automation using Jenkins. It's a build tool. I'll talk about that in a minute. Easier deployments. So up until now, we've been using some kind of combination of GNU make scripts, SSH, rsync, and it was a little bit painful. Also, the whole thing of separate source trees was a little bit ugly. So we definitely wanted to make our whole deployment mechanism a little bit more streamlined. Better developer tools. I mean, in one sense, you need to train up people who are using Puppet in Puppet, but in another sense, you know, you can't just say, well, here's a website, go and read the docs and, you know, use your text editor. It would be really nice to make some more tools that kind of wrap around the whole experience, much like developers have IDEs and API references and all that kind of stuff. You know, make it a little bit easier for them and reduce the boundaries to actually get other people in, because if you've got a ratio of 30-to-1 developers to sysadmins, you want to get some of those guys making your Puppet code for you. You don't want to be doing everything yourself. So testing. So I'll talk a little bit about Jenkins and how we're using it. Basically, if you don't know what it is, it's a continuous integration or build tool. That is to say, it's pretty much just a glorified job scheduler. It's got a lot of really cool stuff in there. It's got a lot of very good source control integration. It knows when your source files are changing, and it will trigger builds. You can chain jobs together. It gives you some very nice reports if you've got something that can export JUnit. Incidentally, Cucumber can. And if you've heard the name before, Hudson, basically the same thing. Which I won't go into too much, but basically, yeah, Jenkins, this is the tool that we wanted to use. And most of our development teams were already using it, so it was a good reason. So we wanted to split our testing into stages. A lot of you may run puppet --noop on the command line. You know, that's a very cheap way you can do some testing, but obviously it doesn't cover everything. So I wanted to express this, this idea of doing some very basic testing to begin with, some slightly more comprehensive testing in the next stage, and so on. The most basic things like, for example, you leave a semicolon off the end of a line. You don't want it to take an hour for that to come back and reach you. You want extremely fast feedback of the very simplest problems, and going on the more complex problems that you hit, it doesn't matter if they take a little bit longer because they are complex and harder to find out. So, as I mentioned, we've got this idea of a few different stages. Simple tests, our lint style checking for hard tabs and Windows line endings, as I said, -- parse only, testing ERB templates. Basically, I wanted these to run in about less than 2 minutes. And at the moment, I think they actually run, including checking out and running the tests and doing everything else. Some of them actually run in about 15 seconds. And then the next stage, compile tests. Oh, I thought I fixed this up. That should really read Puppet faces. So the next stage I wanted to be compile tests. So we actually take the code and we actually run Puppet apply in -- mode. And run some kind of instantiate the resources inside Puppet, but not actually do anything. And for all of our modules, I wanted this to take a little bit less than 10 minutes, hopefully. And then the next stage could be, for example, some kind of integration stage where you actually do a real deployment. And this might be something that you run with VirtualBox and Vagrant, spin up a VM, deploy some actual real resources, maybe test them with Cucumber Nagios or some other mechanism, and then destroy the VM. And that really depends on how complex your applications and what you want to deploy is. But obviously, I mean, you can say, well, this should take less than 10 minutes. The ideal is for all of this stuff to take as little time as possible. If you could have full integration running in 1 minute so that you get the most complex of feedback back within that time, then that would be fantastic. And furthermore, I think it's a good idea to use something like this in production. So it's one thing to run testing in R&D and staging maybe, and then just deploy to production. You go, okay, that's good, that's done. But then you should really continue testing. And I don't mean something like Nagios. I mean something like, you've got your Puppet code and you've deployed it, but how do you know that Puppet code is still there? It's not changed. It's not introducing problems by itself. It would be really cool to do, and this is a term that I've taken directly from Jez Humble's continuous delivery book. The idea of canary testing. Once it's in production, you continue testing and make sure that everything's still okay. And eventually, if we take all of this stuff and we hook it together in a nice enough way, we should be able to do continuous deployment. If you've got sufficient testing in place, there's absolutely no reason that you can't just say, well, I've made a change in this line of code. Let's put it the whole way through and just have it deploying straight to production. If it passes all my tests, then great, it's suitable. If it doesn't pass the test, it's not suitable. If it gets into production and it passes all the tests, but it's still bad, your tests aren't good enough. So something that I've been talking about with a lot of people this week already is this whole API approach. And I touched on it briefly before, mentioning about how we approach this as a software problem. So I believe strongly in making your modules and your Puppet code as reusable as possible. And one of the things that you do quite commonly when you're running a program, you might be using the Ruby API, Ruby libraries, and admittedly you can go to the Ruby Lang website or Ruby doc, I forget, and you can actually click into the code and see what it's doing in the background, but you don't really want to. Basically, all you want to know is how do I use this based on its API, and as I said, a lot of our developers don't have a whole lot of Puppet experience, but beyond that, I mean, it's a waste of time for me to be reading through all my code, all my Puppet code. I just want to see what is the API, how do I use it, and that should be enough for me to just start using Puppet, write my own Puppet code and just use the modules that are already there as APIs. So basically, all of our modules, basically we wanted to apply this to all of our Puppet code as much as possible. Expose a well-defined interface using parameterized classes. We had to remove host, role, and data center specifics from modules. This should be pretty obvious. There's no way you can deploy into multiple data centers globally if you've got some hard codings in there that say, well, this is the mail relay server that I use in San Francisco, for example. Driving configuration through the front door. Again, this is something that I quite strongly believe in. Like a programming library, you don't want to be setting global variables and having data entering your modules in some way that's not entirely straightforward. We've got parameterized classes, we've got defined types, we should be using them to make the path of data flow very clear. Everything enters through that well-defined interface. Obviously, we can't get around things like facts, which are just in the global scope. But as much as possible, things should be going through in a very well-defined way. And as I said, if we follow these principles, we should basically remove the need to look at the code. You're always going to need some kind of documentation. An API specification is not going to be enough for itself, but basically you could equate looking at someone else's module as reverse engineering. You shouldn't need to do that. So as I mentioned, we had some fairly big problems with node definitions, so we decided to write an external node classifier. Best advice I can offer with ENCs is just write one. They're incredibly simple. It can be as little as a shell script and some YAML files. You don't even really need YAML files. You can actually just kind of hand craft the data into YAML format. It's extremely simple. Or if you don't feel like doing that, try Dashboard. It's got an ENC built in. It's reasonably simple, but you could actually do surprisingly quite a lot. I guess it's quite a sticky point in the Puppet community that you need to use an external node classifier if you want to do some reasonably complicated things. But being that as it may, Puppet is a tool. An external node classifier is just another way that we can add value to that tool. So probably not as a surprise. I'm also need to slightly justify why we couldn't work around these problems in another way. So an obvious solution is ext lookup, and it's a fantastic tool. It definitely solves this problem. The reason that I didn't want to use it was it's kind of the equivalent. Now this is a slightly inflammatory comment. It's kind of the equivalent of using global variables in programming, and therefore bad. You have basically what I mean by this is that you've got this this kind of invisible way of data getting into your modules. You can put a module in there and you can include a class, and there's no real understanding. If this is someone else's code, there's no real understanding of how that data gets in there. And if you don't really want to look at that code, there's not really any way you can actually use it. You need to look at the code and figure out, okay, well, I need to supply these variables here. And that's a little bit like the use of global variables in programming, where there's no real, you kind of need to go through all of the code to figure out exactly where something is referenced. And that just doesn't feel like the right way to do things. As I said, there's no well-defined interface to classes and defines. We've got parameterized classes, we've got defined types. We should be pushing all of our data through that in a really well-defined way rather than leaving things up to chance and maybe running some stuff and finding that you don't actually have everything that you needed. And as I said, it requires that you have to code dive in order to figure out how to use the code. So my philosophy is that if you've got a well-defined API and some general documentation, that should be enough to use any kind of module. Incidentally, it's also very difficult to test that kind of code. If you've got some kind of function that has to call out to some external data source, you need to prepare that external data source before you can even run that code in any kind of way. The way that we're doing our testing at the moment is that we've got a separate test directory. If you've spoken to Dan Bodie about this at all, you'll probably be familiar with the concept. You have basically some other Puppet file that instantiates your class or your defined type, and you can run that and it can compile something with some test data. It's very easy to run those tests, just supplying something in a file. So whenever you're pulling out some data from some external source, it makes things a little bit more tricky. So following on from the whole API idea, one of the things that I wanted to do was actually find some way of saying, well, can we get an API out of these modules? And as it turns out, you can. You can actually, without having to actually look into the file, you can generate an API reference for your parameterized classes and your defined types. So this is a bit of code from one of my rake tasks that we run. Basically, in the first stage where we've done our lint testing, we've done our compile testing, before we package up our modules, we generate an API reference for the module. So basically what we've got here, this is no real surprise, we're making a hash where we can include, which we can populate with the actual API reference of this file. Here we're basically saying this is the file that we want to look at. We tell Puppet this is the file that we want to look at, and then we open it for reading. That's all pretty straightforward. We figure out if it's a class or define and pull out the actual name of this thing, populate a couple of variables with whether it's a class or a define and the actual name. Some of this is slightly duplicate code. We technically, if we're following the Puppet module auto-loading standards, then the name of the file should exactly match the name of the class. But I'm just being a little bit paranoid in some of these areas. So here's the real magic. We say to Puppet, I want to find the Puppet resource type of this ID, which is the class or define name, and give it back to me in PSON data hash format of the actual arguments. And that's basically just the hash. And that will actually give us something like, and then at the bottom we just return that to the thing that we're calling. So this is the kind of thing that we get. We know that we've got a class, for example, in this case, postfix, and this is a fairly boring example, but for example, we say, well, we've got a string value, which is the root email. Incidentally, you notice there's no quotes. YAML is, if you're not familiar with YAML, it's smart enough to figure out what is a string value, what is a number that is actually being typed as a string, etc. So that's just string. We've got a parameter called relay host, which is empty, so there's no default for that particular value. INET interfaces, alias maps, and then we've got a final parameter, my networks, which is an empty string. So that's the kind of stuff that we get out. You know, the possibilities for how you can use this are endless. So the kind of things that we can do with this. As I said, canary testing is something which I think could be really useful. So for example, if you generate this API interface and you package it with the module when you're first doing your testing, you pass this module through your continuous integration pipeline. And then you deploy that into production, and then you can do things like, you know, something changes, or actually, no, ideally this is something that you test repeatedly. You can then actually run the same kind of code on your deployed Puppet code and generate these APIs and compare them back to the file that you generated when the module was first tested and see if they've changed. And if they have changed, then you know somebody's changed the actual Puppet code. Admittedly, this only picks up problems in the actual API, so only if the interface has changed to the code. But it is just one mechanism of testing, and it's a very simple way of making sure that your Puppet code is still consistent after it's been deployed. Interface documentation, as I mentioned. So this is probably the biggest use I can see for it. We can actually generate a separate file, a separate reference for this module that can exist separately to the module itself. And people can use that in order to know how to use it. There's also the doc string, which that PSON data to hash method pulls out, which is the, I think Henry covered this yesterday. It's the section of comments just above the definition. And I think Puppet doc uses that as well. So that certainly, if you wanted to provide extra documentation, you could actually put comments there and use that. You could use it to generate web forms. I was trying this week to come up with an actual kind of example of this, but I'm an absolutely terrible Rails programmer. But basically, you could actually use that generated YAML file and then have a web form which you can actually use to generate server templates. So for example, you say, well, I might want to, I want to make a new server template. It's based on a certain application. You have a web form and you say, okay, well, let's pick the environment that I want to use. Inside that environment, you have a number of modules. You pick the module you want to use, and then that module will actually have this API reference for all of its classes and defines. You can then just say, well, I want to use this class. That would then populate a little list that says these are the parameters you want to, that you can use for this particular class. Some of these have got default values. You don't need to specify anything for them. Some of these have got required parameters because they don't have a default. And you can generate your entire kind of server template just using that. Can reduce a lot of work. So part of the work that we did to get around this versioning issue and I guess I didn't actually mention it too much. We had some problems in the R&D environments, actually almost all the environments, where some people would make some changes to a code, to a file, and that would impact everyone. Because everything was being rolled out to a single set of puppet masters, at least in the R&D environments, if somebody made some kind of syntax error, they left off a semicolon at the end of a line. Because we were doing our checking over the entire code set, that would typically stop the rollouts from actually occurring. And then one very simple error would break everything for everyone. It wouldn't actually break anything, it would just stop people being able to roll out. So we definitely had this problem where it was possible for one person to make a very small mistake that kind of halted the work that everyone else is doing. So we definitely wanted to increase kind of encapsulation, keep everything quite separate from each other, but also we needed to solve this problem of versioning of modules. So one thing that I've kind of mentioned a bit is this idea of a common module set, and this is what we call dist. Basically, it's providing platform services, by which I mean the kind of common stuff that you want to use on all of your machines. You know, all machines have got an OpenSSH server running. They've all probably got an NTP daemon running, all this kind of stuff. So there's about 31 modules roughly in our dist tree, and a lot of it is used for like kind of these base platform services. A lot of them also provide APIs for applications to reuse. So for example, if an application needs to use a MySQL server, we've got a MySQL module there. We've got a Java runtime module there, which can be used for setting up a Java environment for some of the applications that are running Tomcat. I was going to say PHP, but we don't actually have that. All these kind of things that the applications might want to reuse so that they don't have to re-implement these basic kind of components. We wanted this thing to be relatively stable, so you know, not changing that frequently. Certainly this problem of some applications deploying into production and then everything breaking because what they need isn't there. You know, that was something we wanted to fix, and having a defined release cycle. So it's a lot of modules. We don't want to be releasing every day, every week even. Certainly we get people coming up to us saying, can we please have some more functionality in one of the modules? We'll say yes, but you know, by the time we want to release that, it's probably going to take a while. You know, we don't want to be changing this stuff very frequently. Mostly, I guess, because we don't want it to be a moving target for the application developers. You know, we want them to say, well, you can develop your application module against this version of dist, and that's not going to be, you know, that's not going to be changing that frequently. And it should be a sufficient quality that app teams cannot resist using it. So I would really, really hate it if someone came up to me and said, yeah, we've got this application that we want to deploy. Oh, by the way, we re-implemented all of the MySQL stuff because your stuff wasn't good enough. You know, it kind of means that we're not doing our job right. But at this point, it's pretty good. There are some things that they do implement themselves, but that should reduce over time. And eventually, we want to delegate maintenance to some specialist teams. We've got quite a lot of specialist teams in Nokia. We've got MySQL teams. We've got teams that specialize in hardware or kernel optimization. It would be really nice if we could hand off some of this stuff to other teams for them to maintain, at which point maybe we'll make it a part of something else other than dist. But for the moment, we've got everything incorporated in this kind of dist idea. Another thing that we wanted to open ourselves up to was being able to pull in things from Module Forge, and we've kind of done this a little bit. I think we were using the sysctl module, but ideally, if we're maintaining this stuff as generic as possible, then we should be able to use third-party modules as well. So I'll talk a little bit about the app modules. Basically, again, they should be generic. I want to treat them as blueprints for how to deploy applications. So absolutely bare bones, no specifics at all. You know, ideally it would just be the whole, you know, package config file service paradigm. A lot of them are a lot more complex, but they should not have any kind of, you know, these should all be parameterized, templated config files as well. That's pretty straightforward. Again, they need to use the dist APIs rather than re-implement functionality as much as possible. One thing which I've noticed happening a lot more recently, which I'm not entirely sure about the solution to is this. We've got some code in some of these modules which actually sets up the development environments. So for example, they might, I don't know, they might pre-populate some database with some information from a dump somewhere. That's obviously something that they're not going to be doing in production. They're not going to be just reloading content into a database regularly, but it's something that they want to automate. And that's fair enough. I can't argue with that. You know, if they want to make their lives easier, developing the applications, then that's certainly something I want to promote. But it's still kind of stepping on the toes of, you know, this is stuff that goes into the module that we deploy to production. It just doesn't quite feel right. And the other possibility would be take that stuff and put it into another module, but then it's kind of living separate from the actual application module, and there's probably going to be some code that they need to duplicate, and that also kind of feels a bit wrong. So I'm still not entirely sure about how that should be approached, but maybe some of you have got some ideas about that, and I'd love to hear about that. So packaging, I kind of alluded to it a little bit, talking about the build pipeline. We do actually package our modules as RPMs, and this probably feels a bit wrong to a lot of you, and I admit that to myself it did feel quite wrong. We had a workshop to ramp up some of our virtualization stuff last year. And one of the guys in that workshop said, hey, so we've got continuous integration going, so we're going to be packaging our modules as RPMs, right? And I was absolutely militant about it. I did not want to package them at all. You know, you can very easily go down this path of saying, well, okay, I've got my modules packaged as RPMs, so then logically I need to deploy these RPMs in some way. So I'll need a Puppet manifest to deploy these RPMs, so then, okay, I'm going to need a Puppet master to control that, to deploy to the next Puppet master, and then whatever that Puppet master is running, that will need to be puppetized as well, so I'll have a Puppet master to control that Puppet master, and it just sends you insane. Like, I'm sure at least one of you has done it, but it seems like madness. But anyway, for better or for worse, we're packaging our modules. Actually, sorry? At the moment, we've got a list of packages that we want to deploy to. It's a little bit complicated because we haven't completely figured it out. In the R&D environments, it's certainly harder because as people are developing their application modules, they're going to be going through, you know, some kind of change. And when they make a change, they want to deploy that to a Puppet master pretty quickly. That part of it is still a little bit quirky, I'd say. In terms of production, I'll kind of go into this in a second, but basically we'll have a list of modules that are suitable for production, and then they just get deployed everywhere. So there's basically a manifest of those files, and all Puppet masters will just say, well, install this. But obviously, it kind of needs to be done slightly out of band. Someone asked me yesterday, which I don't think I actually covered, is, you know, why you're actually packaging your modules. And basically, there's kind of two reasons. One is that if you're using a continuous integration pipeline, you need to have some way of communicating between the stages. This is a piece of code that's actually passed, and I can pass that up to the next part of stage. So you can do this in a few ways. You can have a metadata file which says this part of the code has been tested up to this stage. So the next time you know, you call something else, and then you've got some mechanism for saying, yeah, grab this piece of code and test it in this way. But then you need to write to this file. You need to store that file somewhere. Another way you can do it is by passing parameters between jobs. And that can be something like, you know, arguably a good way that you could actually do this is say, well, I've just tested this particular revision from source control. So therefore, this next stage, you need to check that revision out as well and test that. That kind of slightly breaks down when you actually get to deploying the code. And certainly when, well, I should say for reasons such as you may not have access to your source control repositories in production, you also get some bonuses with packaging like MD5 checking. You can verify after the fact that you've still got working code. In the case of RPM, I'm not sure about Debs, but you can mark certain files as config files, mark certain files as doc files. That can be very useful. And I guess just the tangible idea of, you've got this single file which you can pass around quite easily and deploy wherever you want. Whereas, getting source control tools onto all machines, access to all source control everywhere can be slightly problematic, certainly inside Nokia. So packaging. This may be too small for some of you at the back to read, but hopefully I'll get to distribute the slides and you can have a look at it. It's a very good blog post by a guy whose name I keep forgetting. Basically, dynamic Puppet environment creation, and it doesn't necessarily have to be used with Git. So the way we deploy them, I should say, the other good reason, which is what I'm about to talk about, is with RPMs you can actually do some tricky kind of reorganization of your Puppet code into a particular way. You can call scripts on it and fashion it into something that you can deploy to facilitate what I'm about to describe, which is something that you can't do if you're just checking out from source control. So we deploy our Puppet modules under etc. Puppet modules. No surprise there. Each one of these has the metadata files. These are not the API files that I was describing before, but I'd like to actually unify them. We've got a file called dist, we've got a file called app. The file called dist for app modules, I'll describe the app modules first. So the app file will describe which is the version of this app module that I'm within, and the dist file describes which version of dist that this app module relies on. So we've got now this versioning concept of this application module relies on this version of the dist modules. And whenever you deploy it, you know that it's going to be getting access to the right set of base functionality. In terms of the dist modules, it's only got the one file, dist, which describes which version it is. Using the technique described in that blog post, we've set up our module path, $conf_environments, $environment/app, and the same thing ending in dist. So basically what we do is when we're generating the RPM of this module, we do put all of the files into etc. Puppet modules, but we also populate this environments directory, and we concatenate the actual app name and the version. Has to be only upper and lowercase alphanumeric for environment names, which requires us to sometimes make a bit of adjustment to the actual application name. But basically, we create this environment name for the application version. And within that directory, we have a symlink which points to the correct version of the app files, and a symlink which points to the correct version of the dist files that that application module uses. And then basically we just drive our versioning from the Puppet environment. So we put all of our actual machines into the right environment, and they will automatically get pointed to the right version of their Puppet code that they need. So as I mentioned, our spec file, which creates the RPMs, is the one that's actually doing the symlink creation for these automatic environments. And that's something that you could build into your source control, but you'd be having to put that into every single module. And it's a bit of, it's kind of housekeeping stuff that you don't really need to have in your file repository. It's kind of cool that we can just have this in a single spec file, and then it can, we can use this on any of our modules, so that's pretty cool. Yep.
Just a question about the environment. How is that bundled? Is that bundled inside the RPM? So the RPM knows which environment it belongs to?
Not quite. The RPM is just a bunch of files, but basically, when we're building from Jenkins, we pass some things to the rake task that in turn passes it to RPM build, and says this is the version of the app which comes from the job name. This is the name of the app which comes from the job name, the version of the app which comes from the metadata file, and the version of dist that it requires which comes from the other. Are you talking about this part? Okay, so we basically say our environment is a concatenation of the app name and its release. So, for example, if you've got an application...
You can't mix modules from different environments that they coexist.
At the moment, our kind of paradigm for this stuff is we have an application, and that will have... we're talking about quite large deployments here, so we might have hundreds of servers which which run the service that generates the map tiles. I mean, we're not really interested in running multiple services on the one machine for these things, just because they're doing quite a lot of stuff. So the map tile service, for example, will have its own environment. We don't have multiple applications running from the one environment. And if we do, they're generally a set of applications that are related. And they might be several modules within the one kind of thing that we can build, but that will be kind of under the umbrella of, map tile might be under an umbrella of maps. And there may be, a type of map tile server that serves PNGs for the, just for the streets and stuff. And then you might have another type of server that serves the JPEGs, which has got the satellite imagery.
So your environment contains the version of the application as well?
Yes. Yes.
Do you have to change the environment for all of your clients every time?
Whenever we need to upgrade, which is what I'll cover in a second. So the real important thing about this is that we can have multiple versions of the same application on our Puppet Masters. And not only that, but if we go, okay, we want to release R2 version of this particular application, as long as the modules pass, we just install it. And I think this is coming back to kind of what you were mentioning before. We just install this onto all of our Puppet Masters. Until a client machine actually references that environment, it doesn't get used. So we're pretty happy that we can deploy code, and we know it's not going to break anything until we actually use it. It may that was incredibly poorly phrased. It probably okay. So as many of you will know, environment changing is a real pain in the ass. So yeah, there are many tickets outstanding. Please put pressure on your friendly local Puppet guy to address these tickets. Yeah, environments can only really be driven from the client. So we hit this problem. We're really trying to use environments, and then of course it comes back and bites us in the ass. So this is code that we have living in our external node classifier. Basically, what happens is a client connects. If we decide we're doing an upgrade from one release of the application to the next, we put information into our ENC that says, well, these machines are now going to get the next version. And then the next time each of these nodes connects, it's going to try and connect as the old, using the old environment. And one thing that we definitely hit before was when we were doing these things, sometimes the next version of, we'd reorganized our application modules somewhat. We'd renamed some of the classes. The client connects and says, yeah, give me my catalog. I'm in this environment. But the node definitions would say, well, this machine needs to get these classes. But then the classes and the environment wouldn't match up. And it would be trying to reference classes that didn't exist in its previous environment. And then basically the catalog would not compile. And then there's absolutely no way you can ever actually fix that machine using Puppet. You have to do it manually, absolutely. So, so we built some of that functionality into the ENC to work around that problem. And basically, this is the part that kind of, so what we do is we determine which environment it was running as before, have a look at our ENC code and say, do these two things match up? The new environment and the old environment, are they the same thing? If they're not, then we just kind of shortcut everything and change the environment first, and then on the next run, we actually give it what it wants. So this part determines the previous environment. So we take the FQDN off the machine, and basically we just dive into the var lib puppet YAML facts directory, which has got the, when the clients connect, the first thing they do is they actually make the request, which has the base 64 encoded list of facts. That gets stored on the Puppet Master first before it actually calls the ENC. So we can have a look in that machine, into that file, and determine which environment it is currently running as. So here we actually look at this file. If there isn't a file there, then we raise an exception. I don't think that's actually possible if you've got a working Puppet Master, but anyway, I'm usually quite paranoid about these things. Here's the guts of it. We basically load that facts file. We create a Puppet node facts object from it. And inside those values, we have just a value for environment, and that gives us the old environment of the machine. That's just given us. So here's the next section. Basically, this is in the kind of main runtime part of the ENC. We check that old environment that we just got from the fact file. We check it against the new environment that we get from our actual ENC configuration files. If they don't match up, then basically this hash, which we call Y here, is what we've already populated with the YAML that we were going to serve to the client, or going to serve to the Puppet Master for this client. If the environments don't match up, we just throw it away, and we shortcut everything and say, we only want to instantiate Puppet Client with the new environment passed in as a parameter, and because we also manage the Puppet Master address in there, we throw that in as well. So basically, we just shortcut everything and just say, for this run, you just get the Puppet Client class, and you fix up your Puppet config, and then the next time you run, you'll be fine. And incidentally, some of you may know YAML is really irritating in that it deduplicates values, so we throw in a clone in there for good measure, so that we don't get any funny stuff going on. Did I have some stuff there? Yeah, so that's basically how we do it. Our external node classifier is somewhat complicated. The code is actually pretty damn easy, but we've got this concept of, so in order to effectively deduplicate all of our configuration, we've got all of these different kind of levels that configuration can be specified as. As I mentioned before, we've got this concept of sort of a global thing. We've got data centers. All of these other levels may be, this really turned out pretty poorly with the slides as far as the coloring is concerned. But basically, we've got, things that you might express at data center level, data center plus environment, application environment. Most of these won't really make too much sense, but basically these are levels that we've determined are levels that we will actually want to express some kind of config at. So first thing you might notice is that environment does not have its own level. So if you think about, well, let's take QA. If you're talking about multiple applications, multiple data centers, multiple, that's pretty much it. Multiple data centers, multiple environments, multiple applications, and you think about, okay, what could I actually put into this concept of a QA environment that would span all applications, all data centers? I couldn't actually come up with anything. You know, there's nothing, we've got different QA teams for different applications, so it's not the same set of users for everyone. We've got different kind of, obviously different data centers have got different settings, but in the context of QA, I didn't see anything that we could actually make kind of common to that. So these only represent things where we actually want to specify some configuration. And in the case of some of these things, this one's a little bit hard to make out. App plus role plus release plus environment. They're getting very specialized, but it's basically, these are use cases. So we're going from, least specific and the lowest precedence, and going down the chain, we can override these things until we've got individual nodes at the bottom, and that's where we can override anything pretty much. And if you're thinking about the code, this basically is, we're basically doing a bunch of reads of files using the YAML library, populating hashes with them, and doing hash merges as we go down. So any value that we've already specified higher up, we just override that if something lower down specifies it. So as I said, we're using YAML files. They kind of look a little bit like this. We've got this concept of, so classes. As I mentioned, we've got this idea of a platform class that has some parameters. And this is how we basically do the value substitution and overrides. We've got this, this idea of a variable in the context of our ENC. So this is just a variable that can be replaced at any level below. It can be replaced at any level within that override order. And for example, in here, this might represent some variables that we have at the data center level. If we've got a data center in New York, for example, we've got a particular Yum repo server there. But if we want to override that, to replace that, we can actually replace that value at any level below the data center or whatever. That substitution is done at the end. How am I going for time? A couple more minutes. Okay, I was going to demo a little bit about like some actual code generation in our ENC, but it's not that interesting. So the future, where are we going with all this stuff? Maybe some of this stuff looks very rough. Some of it is. Hopefully some of it is slightly exciting to you. I know that I'm certainly excited about actually getting to solve some problems. It's kind of cool to write some real code after so long. It's a lot of fun. But you know, I'm being paid to solve these problems. So unfortunately, we don't have our deployment strategy entirely worked out. We've certainly made some leaps and bounds with this stuff. As I mentioned before, this whole idea of how to actually deploy our Puppet modules as RPMs, I mean, this is something which is necessarily a little bit tricky. Specifically, if we're talking about the R&D environments, the idea of, well, basically what I'd really like to see is if people are building their Puppet modules in a similar way to their applications, you're going to have, you know, trunk, your feature branches, and hopefully tags, which are your actual releases. And a lot of the teams are using Maven, which kind of takes care of some of this stuff, but it would be really nice if we didn't have to use something like Maven. That's probably a phrase that's been uttered infinite times in this universe. Some way of automatically saying, well, you know, I've just made a branch of this module, so please automatically build that new branch and then get that deployed quickly so that I can test it straight away. That kind of stuff, you know, it also ties in very closely to how you're managing your source control. Subversion, Git, I guess those are the two main ones. They differ quite wildly in their concept of how they manage branches and tags. Not to mention the fact that a tag or a branch, for that matter, in Subversion is not exactly immutable. It's not in Git either, incidentally, but anyway. These kind of things of how we build our stuff into packages and deploy them, it's tricky. So there's ongoing stuff about that. Developer workflows, this is always an area that gets neglected. I mean, we're systems administrators. We're often paid to have you know, high uptime on our production servers, get lots of deployments out there, and we don't really care about the developer stuff. But let's face it, I mean, we've got to worry about that. Especially if you're like my team, and we've got so many more developers out there, it would be really cool to just get them into writing Puppet code. And we want to break down as many barriers in that area as possible. So hopefully if you're paying attention in the presentation yesterday, Cloudsmith and their Geppetto tool, that looks really cool. I'd like to see our developers using that. You know, and certainly if they're using Eclipse already, that makes sense. But not entirely that. It's also just about kind of making not just the tooling, but these things like making it easy for people to test their code, deploy them to a real Puppet master, and for them to see that their code is actually really working and it can actually be promoted up the CI chain. And some of the stuff that I mentioned earlier about API interfaces as well, you know, could really help with that. So that's pretty much it. I really want to thank Luke and the Puppet team for making such an awesome tool. Lots of thanks to Dan Bodie and some of the other professional services guys. They've been a massive help to us over the last year or so. Certainly helped us solve a lot of these problems. And I mean, there's going to be a lot more of these kind of interesting problems to solve in the future. And yeah, look, if you're in the market for a new job, we're hiring. We've got a lot of positions to fill, and there's a lot of really cool stuff that we're doing in this area. So, yeah, thank you very much. So, I don't know how we're going for time, but if there are any questions. Awkward silence. Always good. Yes? Yes, definitely. That's kind of the question was, does our ENC allow us to use parameterized classes? And I would say, if we didn't have parameterized classes, we almost well, I don't know. No, you'd still use the ENC, but yes, the answer is yes. Where was it? I've already gone past it. Yeah, that's kind of the cornerstone of what we're doing. So here, for example, this thing, platform, that's just a class. And that kind of wraps around a lot of our disk modules. So we pass things like NTP servers, and within this platform class, we then call the NTP, I guess it's the NTP client class, I can't remember off the top of my head, and just pass those NTP servers in. So I guess some people worry about having this never-ending hierarchy and chain of classes that call other classes that call other classes. At the moment, our system is only really one class deep, or two classes deep. So platform wraps around other classes, but that's as far as it goes. Other things like this contrived my app class, that's just got a version. That's just it. We just call that. And these things kind of exist in, for our applications, we've got like, I think I had it before in that. So applications kind of live in this zone here. So we have an idea of an application and a role. So as I was saying before, we've got like, so you might have a concept of a map tile server. One role of that might be serving PNGs. Another role might be serving the satellite JPEGs. And we have a file which describes each one of these roles. And that basically just has something a little bit like this, but obviously a lot more parameters, that just says, this particular application role, it's made up of these classes, they take these parameters, but we don't actually fill in anything at that point. It's just an absolute blueprint. This is the configuration blueprint for this particular application role. And then at any one of those other layers, we can specify the values. So for example, you might say, well, in this particular data center in production, we want this particular map tile server to spin up 10 instances, whatever that might mean, and use 2 gigabytes of memory. And that's kind of, we can actually specify our values up here, and then they get used down here. And then certain releases, they might say, well, we've made our thing more efficient, and it only needs to use 1 gigabyte of memory. So then in that next release, we say, for this next release, we just pass in that 1 gigabyte value, and that overrides what we set up here, just for that one release. So all of our previously deployed machines still use the old value. And that's kind of cool. We can separate things like that. Yep.
You mentioned the duplication program with YAML.
Yep. Whenever I try to actually create some and show it to someone, it never appears. But basically what YAML does is if you reference the same variable multiple times, then it will try to make, basically the first one will say, this gets this ID 001, and then anytime you've used that variable again to populate the YAML's source hash, it will just say, look back at ID 001 and give you the address. I should say, like, functionally, it's not a problem. There's absolutely no problem with that. The problem that I have is that I want YAML to be used as, by humans. And, aside from that one problem, it's extremely readable. Like, you can manipulate it by hand. It's really cool. But when you get a file, it's only even just a few lines, and you start seeing these ID tags. It's like, why bother? So I just make copious use of cloning values so that I can just make my files readable. Stages? In what sense? Oh, we do now, actually. Yeah, none of this stuff really solves the staging problem. So we do use, I think in the platform, we define, Dan can probably correct me, I can't remember. We just define that yum stuff has to happen before everything else. Is pretty straightforward. In terms of everything else, I think it's all pretty much okay. That's really the only thing that really makes a problem for us, is just setting up yum repos before we need to use them. That's about it. Yeah. Anyone else? Confused everyone successfully? Okay, thanks again.